Okay, so I'm Akhilesh Mani, right? Here I'll be your trainer. I work in a software company as a tech lead. So today we are going to discuss very basic topics of Android, right? So let's see. Okay, so course objective is to learn how to develop professional enterprise level Android apps, right? And here we are going to discuss the architect of Android applications, life cycles of various components, manifest, intent, and intents. So we will discuss about these terms later on. So let's start the topic. So first we will discuss what is Android, right? So Android. So this is Android, right? So if you talk Android, we have two things. First is mobile, right? Like why we have a mobile, Android mobile, and second thing is we have OS, right? So we have two things. Android, when I say Android, we have a mobile, and inside a mobile we have some hardware, right? And that hardware runs with the help of OS, right? Which is based on Linux kernel. So Android is two things, or you can say two things. If you combine the two things, we have an Android mobile, right? Which operating system is known as Android OS, which is based on Linux kernel. Altogether, we say Android mobiles, right? Android is a software platform and Linux kernel based operating system for mobile. So basically, the operating system which Android used is based on Linux kernel, right? We'll discuss about Linux kernel in a few minutes. It is a open source software, which means it's freely available, right? So open source softwares like Linux, because Linux kernel is open source, right? And it is a freeware, right? You can say open source software. And Android, actually, it was founded in 2003 by these guys, Andy Rich, Nick, and Chris, right? As a part of Android Inc. startup, right? So in 2003, they have started a company like Android Inc. And later on, in 2005, Google bought this company in $50 million. And now Google is working on Android from 2005, right? And Google is continuously working in Android, enhancing their APIs, enhancing their hardware. From 2003 to 2005, now we have very rich devices, like we have a devices which have very rich functionalities, right? So Google is still working on it, and OAH, Open Handset Alliance, is a group of companies which allowed the use of open source code of Android and develop application, right? See, Android is a open source. When I say open source, that means any company can come and say, okay, now I'm going to redesign the Android operating system. That means we have many vendors, right? We have many vendors which sell Android phones. Like let's say we have Samsung, we have Android itself, like Nexus, LG, Motorola, right? They all have Android operating system in their phones. But if you see some features like camera, or you can say the gallery, right, and many other applications like contact applications, they looks different. Even if you open the settings, they look different, right? But all they are Android operating system, right? We can say all they are based on Android operating system, but they have redesigned, or you can say they have customized the Android operating system based on their own needs, right? Let's say Samsung, if Samsung introduce a new hardware, right? Let's say many many Samsung phones and LG, Motorola, they have a fingerprint sensor, right? And many phones, they don't have fingerprint sensor. So that if you go to implement finger sensor in your application, then you have to use third-party library of Samsung. If you are going to give a finger scan functionality in your application, then you have to see which phone is this, right? Your application have to see, okay, this is a Samsung phone, this is a Micromax phone, or this is a Motorola phone, and based on it, it will pick up the third-party library. We will discuss it in a few minutes. What is third-party library and what I'm saying about third-party or the driver, right? Okay, before going forward, let's discuss very basic of kernel. Okay, so we were discussing about Linux kernel, right? So first, let's discuss about kernel. Then we will discuss about Linux kernel. So what kernel is, right? Now, before kernel, let's discuss one more thing. Say this is a device, right? When I say device, that means mobile, right? It's a normal term which we use in mobile technologies. When I say device, that means I'm talking about mobile, right? So let's say this is a mobile or a laptop, right? See, now what this contains some machines, right? These are the machines, let's say. And machines may be a camera, a Bluetooth device, right? A Wi-Fi device, or any circuit, whatever, right? Now, if I say this is a camera, let's say this is a camera, right? This is a camera, let's say. Now, this is a device. This is a device, and inside the device we have a hardware, camera hardware, right? Now, when I say open the camera, right? What we do? We just open the application and we just tap the icon, and that icon opens a camera. So basically, what happening is we tap on UI. That means a user interface. User interface, that means camera button. You tap on the UI, and it sends you can say sends request to camera hardware, right? You tap on the UI, it sends the request to camera hardware, right? And then camera opens. Like it looks very simple. We tap on the UI, it send UI, that means the user interface, it send a request to camera hardware, and then camera opens. But internally, what happening is when you tap on the UI, you say Android, right, to, let's say, tap on the UI. So when you tap on the UI, you say Android framework to open a camera hardware. But see, camera is a hardware, right? Camera is a hardware which is installed inside your device. Now, when you say Android open the camera, what Android does, it sends a request to hardware. When I say hardware, that means camera, and every hardware have its own driver, right? Driver means camera hardware, right? Now see, camera hardware has some protocol. When I say protocol, that means when you open a camera, it understands that, okay, now this request has come, now I have to open. Now this request has come, now I have to close. Now this request has come, I have to increase my brightness, I have to decrease my brightness, I have to rotate, I have to open the front camera, I have to open the back camera, right? So all these things, or you can say the instructions which can be understood by the camera, right? It is written in a software, right, which is specifically designed for camera hardware, right, which is known as a camera driver. If you have used the previous Windows version like XP and all other versions, right, at that time, if you format your computer, you have to install the drivers like camera drivers, audio driver, video driver, or graphic drivers externally, right? But that why was we doing these things? Because in your laptop or in your computer, you have those hardware which runs on some third-party libraries, right? Or you can say there's some third-party drivers which runs the camera or those hardware, right? So Android sends a request to camera, right? Or basically it sends request to driver, right? You can say it sends request to camera driver to open the camera, and then it's open the camera, right? So basically Android deals with this driver, right? And this driver is written in C and C++, right? Because this operates the hardware, so it's written in a C and C++. So Android sends a request to some code which is written in C, and that code sends a request to its hardware. And this Android is written in Java, right? So we send request from Java to C++, and then C++ send request to its hardware, and then hardware opens. Similarly, it sent the request to camera, and camera sends back its response to driver, and driver then it sends back the response to Java, right? But the thing is, you have to only work in this Java, right? These things you don't have to work on these things, right? This is already done by the Android, right? Or if you are using any third-party hardware which is not installed in an Android phone, then that third party, like that means the hardware, whoever designed the hardware will give you its driver, right, to operate it. Okay. Now this things not only works in camera, this work on Bluetooth or in your Wi-Fi, right? And many other hardware which is installed inside your phone, right? So this pattern not only works in phone, this pattern works in your laptop, in your computer, or in any other hardware which we are using, like your camera. If you're using a camera, let's say a digital camera or a DSLR, right? When you click a photo, basically a driver is installed internally, and they have some hardware which operates. So this is what OS does, right? Okay, now coming back to kernel, right? Whenever you tap a camera, Bluetooth, Wi-Fi, anything, that means whenever mobile sends a request for any operation to operating system, this request is operated by the kernel, right? So this kernel. So whenever you send a request, right? Whenever you tap a UI, before getting this call to Android, kernel decide what to do, right? You send a request, kernel get the request. Now kernel decide, okay, I have to open this camera driver. I have to open a camera, right? So basically, in operating system, kernel is a program. If I say this is my operating system, this is let's say this is kernel. Let's say. Right? In operating system, this is a kernel, right? And whenever you send any request for opening application, for sending a request to cloud, anything, right? So whenever you send any request in your operating system, in your mobile, this kernel will operate everything. Everything. What are the everything? Everything. That means you send a request to open a camera, kernel have no, okay, this is a request, I have to open a camera. Kernel will decide the memory area where the camera application is going to load. See, whenever you load any application, right? You open an application. Let's say everyone is using Android phones, right? So you know what is opening application. You open an application, your application will take a memory in your phone, right? Now, whenever your application is going to take a memory in your phone, who decide the where your application is going to take a memory in memory area? Kernel decides, right? Kernel not only decide these things, kernel do many other things, right? So this is a very basic things which kernel does, right? Kernel take a request. Now kernel decide where your application has to open, right? Kernel see, okay, this is the valid request, this is the invalid request, right? So every request which you send to OS will pass through this kernel, right? And this kernel is a program. Right? So this kernel is obviously a program, and it loads in a separate secure memory area, right? It operates the operating system and applications, and this kernel open in a secure memory area in your phone, right? So that no one can hack this kernel. So Android is a Linux-based kernel. When I say Linux-based kernel, that means your whole application has only one kernel, one entry point, right? Your phone or your operating system has one entry point. That is your kernel. So in Linux, we have only one kernel from where we send a request, right? And kernel will decide what you have to load, right? So this is a very basic of kernel and Android mobile. So before going further, you can ask any questions if you have. Okay. So now let's see the slides. Android and its features. So Android supports media, right? Media, that means when you see a video, let's say, okay, I think we have a question. Yes, obviously, kernel interacts with the driver. Whenever you send any request, kernel send the request to driver. Kernel operates everything, right? So initial point of every software or driver in your application, which is based, or you can say in your operating system, which is based on Linux kernel, will start from the kernel itself. Okay, so Android supports this media, right? And media, when I say media, that means these formats: AC, AMR, JPG, PNG, GIF, right? Language is used in kernel is C and C++, right? And writing a kernel is basically it is a protocol, right? So whenever we write a kernel, it's based on a protocol. You have to follow those protocols before you're writing the kernel, because see, many hackers are there. What they will do, they will try to hack the kernel. They will try to control the kernel, because kernel operates everything, right? So it's based on the it's based on some protocols, and from many past years, many developers are working to enhance the kernel structure, right? So there are many things before writing the kernels, but yes, it's based on C and C++, because see, you are going to operate the memory, like the hardware things, right? And we have GSM, we have NFC, Bluetooth, Edge, 3G, Wi-Fi. So these are the hardware dependent: camera, GPS, compass. Now mobiles have many other things also, like we have a sensors in mobile. If you play games, right? Whenever you are playing a game, let's say this is your mobile phone and you are playing a game, right? When you tilt your phone, your car goes this side. When you tilt your phone, your car goes this side, right? Left, right. So what actually this is, your phone is able to get the movements, right? It is able to get the movements. And which way? If I say this is a axis, x-axis and y-axis, right? Whenever you tilt your phone in this position, right, or in this position, right, your phone is able to understand that, okay, now I'm moving, right? And this is actually done by the sensors which is installed in your phone. Now your phone is able to get the temperature. So temperature is a device which is installed inside your hardware device, that is your phone, and it has a driver. It calculate the temperature and send the response to the Android application. Yes, you can create your own drivers, but before that you have to get everything. You have to know everything about Android application, like Android operating system, right? So if you see in many cars, like in Audi or in Audi, I think in Mercedes also, or they have the Android locks, right? So basically you can lock your car with your phone, right? You can operate AC with your phone. And if you see, you can also control your TV. If your TV provides Android connection, then you can also control your TV, like you can change the channel using your phone, right? So see, what these things are, they have a driver, and if you are going to create a driver, obviously you have to know about the hardware, how hardware is working, right? And based on this hardware, you have to write a drivers, right? Drivers, that means you have to send the signals to the hardware, right? And based on this, you have to write a driver in C and C++. Then you have to write a layer, which layer is going to connect with Android, layer is going to connect with iOS, right? So this, see, what you have done, if you say you are going to create a driver, what basically you are going to do is you are going to create a hardware. This is your hardware, right? Which is this is your hardware, and let's say this is your C and C++ code, right? This is hardware, and this is your C and C++ code, which operates this hardware, right? Now you need a layer which communicates with Java, let's say, or let's say which communicate with let's say Swift or any other language. So basically, this is this hardware which is created by you. Then you create C and C++ code, which is basically your driver. Now you have to write the layers, right? So that you can, like, you can say driver for Android, driver for Swift, driver for any XYZ, right? Swift, when I say Swift, that means for iOS, for Windows, for any other things, right? So you have to create different drivers for different languages. Basically, the internal code of C and C++ will be same, but before that, you have to write a layer, right? This layer, that means a code. You can say your code is written in C++, and you want your C++ code to get called by Java, called by Swift, called by XYZ, any language, and you have to write a layer, right? And this layer will get the request and communicate with Java, communicate with Swift, and communicate with XYZ. Because if you send a driver to any, or you can say if you send your driver to any application, then that application have to know the language in which the application is written, right? Okay, so moving forward, these are the releases of Android: Cupcake, Donut, Eclairs, Froyo. The very basic version of Android was 1.0, right? And but that Android, that version don't have any like name, right? So Android is named from 1.5: Cupcake, Donut, Eclairs, Froyo, Gingerbread, Honeycomb, Ice Cream Sandwich, Jelly Beans, Kit Kat, Lollipop, Marshmallow, Nougat, right? Now we have the latest version, Oreo 8.0. So these are the versions, right? So when I say versions and when I say API level, see, versions, that means the OS of your operating system, right? The OS of your phone. If you go to your settings and you see the device information, you will see the OS, what the OS based on. Like it's based on Nougat, it's based on Marshmallow, it's based on Lollipop, whatever. And every version has its version code, 7.0, 6.0. The KitKat has many versions, 4.4, 4.4.4, 4.4W, 4.4W.2, right? And with this, we have also one more thing, that is API level, right? When I say API level, there are two things. One is Android operating system code. Second thing is API level. Now, whenever a new upgrade of operating system is introduced, the API level is API level. That means the Android SDK. Right? We will discuss about SDK in a few minutes. The Android SDK level got increased, right? So I will show you what API level. Keep this word in your mind, right? When I show you how to install Android. So these are the versions, right? What are the similarity among different versions of Android release? So these are the questions, you can think on it. And see, if you are if you're an Android user, then if you're using Android phone from last 2-3 years, then you might see that in different versions we have different upgrades. Like we have upgrades in camera, we have upgrades in the UI. Right? Many things are get upgraded. Which is the latest version available in market? So 8.0 Oreo, which is the lowest version, which devices are available in market. So I think 4.4 is available, right? No one supports Jelly Beans, right? I think KitKat is the last, and some device also support Jelly Beans. Now these all ice cream sandwich, honeycomb, gingerbreads, no device, no one support these things. Whenever we also, when we create the applications, we don't give supports to versions lower than 4.4 because we don't have any device, right? We don't have any device which supports these lower versions. Okay, now this is Android architecture, right? So we will discuss about this Android architecture. So why previously I have explained this Linux kernel and all those things, because I want to explain you this Android architecture. Okay, so let's discuss about this Android architecture. Okay, so let's start with very basic, very lower level, right? Not basic, very lower level. That is your kernel. Then we will move to Android runtime, libraries, application framework, and then applications. Let me open. This is your Android website. Right, so this is your Android website, and if you see this thing, this is your Oreo, right? So this is the very latest version. You can see the Android Oreo. We have many updates in Oreo, like let's say you can see the Instagram messages on the top, right? So whenever you tap here, you can see the message here, and you can see this. Basically, I want to introduce you this website so that you can see the Android development. If you want to get a reference of any API, you can see this. You have, just go to develop, and here you can see the building tools, right? They have many other versions. So Android support one new language which is introduced by Google, and that is Kotlin, right? But we are not going to use Kotlin here. We are going to use Java, right? So Kotlin is a new language which is specifically designed for Android, right? But we will use here Java, which is mostly used by 90% companies use Java. So we will use Java. So if you want to get API guide, you can see this is your API guide. App fundamentals. Okay. So this is your updated latest platform architecture. Let me open this image in a new tab. This is your latest, right? See, it's so similar. Application framework, libraries, Android runtime, Linux kernel, right? And if you see here, we have Linux kernel drivers, then hardware abstraction layer, then we have native C, C++ library, runtime, Java API frameworks, and system names. So, okay, let's start with this Linux kernel, right? Linux kernel. So now we know what is Linux kernel, right? Linux kernel is which operates the driver, right? So if you open an application, let's say when I tap on the UI, right? Basically, we are going to sending a request from a touch screen, right? So I have a touch screen, right? This is my mobile. Let's say this is my mobile, and right, this is my mobile, and let's say here I have a contact application, right? I tap on the contact application or any other application, WhatsApp application, Facebook. When I tap here, what actually I'm doing is I'm just tapping on a hardware, right? I'm just tapping on a hardware, and this hardware is a touchpad, right? I'm just tapping on the touchpad. Now this touchpad have a driver, right? This touchpad have a driver. I tap here. Now driver send a request to kernel that okay, this I get a request from this touchpad. The request is for opening the camera, opening the WhatsApp application, opening XYZ any application, right? I tap there, and actually they have only given these things like camera, Wi-Fi. So this is categorized in various parts, right? So I'm just talking about the display. You tap on the display driver get invoked, right? And this is invoked by the Linux kernel, and Linux kernel then send a request to the specific application for which the request has come. Similarly, it is for camera, Wi-Fi, IPC binder. IPC, that means inter-process communication, right? And audio, keypad, shared memory, Bluetooth, USB, Wi-Fi, shared memory. Now let's discuss one more thing. Let's say I have application 1, application 2, and application 3 in my phone. Let's say application 4 also. Let's say I have 4 applications in my phone. Now, what I want is I want these applications to send their data to each other, right? But this is actually not possible. What I want to say is, in your phone, in your Android operating system, your application runs in its own sandbox. Every application in your Android runs in its own sandbox. When I say sandbox, what that means? Sandbox is a secure memory area, right, for every application. That means, let's say, I have a house, right, and in my house I have 10 rooms, and every room is detached from the other room. That means a person inside a room can't interact with the person in the other room, right? That means your applications runs in a separate memory area. No other application is allowed to use the memory area using by the application, right? So this is actually not allowed, right? This is actually known as a sandboxing. Sandboxing is a process which is not only used by Android, it's also used by many other operating system, right? Sandboxing, that means your application runs in its own memory area. It is not allowed to access the memory area of other applications, right? And similarly, other applications are not allowed to access the memory area of any other application, right? This is known as sandboxing. Now, why we do this? We do this because in mobile, we have a limitation of memory, right? In mobile, we don't have the memory like we have memory in our computers, right? In mobile, we have lower memory, lower RAM. CPU is also not very strong as compared to the laptops and other laptops or the CPUs, right? So this sandboxing is introduced so that memory can be used more in a more good way, in a more better way, right? So this is actually a sandboxing. Now, if you want to interact with the application, right? If this application want to send a data to this application, we have a concept, we can send this data, but we have to create one thing which is actually known as a content provider. We will discuss about the content provider. It's an Android component. I will give you a simple example of content provider. Gallery. Gallery is an application, right? And whenever you open a gallery, what I have told you is I can't send my data to other application, right? But if you see, we have a gallery application. I select a image and I share it to WhatsApp, I share it to Facebook. Now what I'm doing, I'm just sending the data of gallery application to other application. Similarly, if you see, I have contacts in my contact application, right? I open WhatsApp. When I open WhatsApp, I can see the contacts which is in the contact application is WhatsApp contact list. Now what WhatsApp is doing? WhatsApp is getting the data from contact application contact application, right? So basically what it is doing, it is getting the data from other application. Now this sandboxing is not in use. No, sandboxing is still in use, but to share data between the application, we have to use content provider, right? If this application want to send data to this application, it can't do this directly. Basically, it has to create a content provider, put this data to content provider, and then this application will come and get the data from this content provider, right? So this is basically a bridge, right? Content provider actually is a bridge where we send the data from one application and then other application come and get the data, right? So this is a common memory area which can be used by the applications, right? So every application can create multiple content providers. So this is actually sandboxing where we can't share the data between the application. Every application runs in its secure memory area. And second thing is, if you want to share the data, then you have to create a content provider, right? Before that, let me tell you the Android components, right? Android is based on 4 components, right? And these 4 components known as activity and service, content provider, and broadcast receiver. These are the 4 components in which Android is based, right? We will start with this activity, right? We will start with this activity. Let's say, I think in next class, We'll start the activity, then we'll go further with service content provider and broadcast receiver. So you first we will start learning. We'll start learning UI designing. Right, I will explain you how we can create a UI designing, a UI in Android. Then we will go forward for services and other things. Right, so activity is basically attached with your UI. So we will discuss about this in that round. For now, let's come back to the shared memory, right? See, this is the shared memory which I'm talking about. So shared memory, that means content provider, right? So actually this was an important point, so I explained it. Similarly, we have audio keypad. We have many and many other drivers, right? Audio, not only audio keypad are there in mobile. Mobiles has sensor and many and many things. I think the people who are from the electronics know it's better, right? How many hardware are installed in a device, right? When you open a device, you can see there is a motherboard, and in a motherboard we have many chips, right? The small chips, circuits. Although all are operated, like all the devices which are installed in the mobile is operated from their driver, and these drivers are operated by the Linux kernel. So this is a very basic, very bottom level. Now, on the top of this, we have hardware abstraction layer, right? If you see this, hardware abstraction layer, HAL, right? They have updated there. Actually, previously, this was the Android architecture, but now in Android, like in developers side, they have updated it, and now they have introduced one more layer actually, right? So actually this part is also, this hardware abstraction layer is a part of Linux kernel. Previously it was a part of this, but to define and to explain it in more better way, they have introduced this one layer so that people can understand, right? Hardware abstraction layer provides standard interfaces that expose device hardware capabilities to the higher level Java API framework. The HAL consists of multiple library modules, each of which implements an interface for a specific type of hardware component, such as camera, Bluetooth module. So actually, this is this layer. This is kernel layer, and this is the layer which I was talking about, right? See, I have written a code in C and C++. Now I want to run the code, run my driver in a phone which runs in a which is based on a Java, right? Or you can say I want my driver to operated by the application which is written in a Java, written in a Swift, written in XYZ any language. Now, how can these language understand, right? Basically, this should have to understand this, that let's say this is my application, right? Then this application should have to understand that I get a request for doing an operation, right? That means the language. This is basically a language. So we have to write a layer. When I say layer, that means you have to create different drivers, right? Or if you want to combine it in a one separate application, then you can also do, right? So basically we write a layer in which, let's say layer for Java, right? For Java application, layer for Swift application, layer for any other languages, right? Hardware abstraction layer, like audio, right? I want to open the audio application from a Java application, but audio driver is written in C++. Then you have to write a layer. You have to write abstraction layer, hardware abstraction layer, right? See, it's a hardware abstraction layer. Abstraction, that means you don't know what is written in C++. It is abstracted, right? You know only Java. You know that open method, you have to call the open method to or let's say you have to call a start method to start audio, stop method to stop audio. You don't care what is written in C++, right? You know what you have, you know Java, then you have going to write a code in Java. So this is basically a layer. You are using a Swift, then you will call a method of Swift, because you don't care what is written in the abstraction layer, right? C and C++. So this is basically a abstraction layer so that you can basically write your code in different languages, right? So driver, and above the driver, a abstraction layer so that my Java API framework can communicate with this C and C++. Because see, whenever you are going to write a code, you are not going to write a C and C++. You are going to write a Java code, right? But this is written in C++. So we have an abstraction layer. We send a request to abstraction layer in Java language, and that abstraction language convert my instruction in C++ using JNI, Java Native Interface, right? And NDK, right? In Android we have SDK, Software Development Kit, and NDK, Native Software Development Kit. Basically, NDK is based on C++. If you want to operate C and C++, you can use the NDK. So, any questions in this Linux kernel and hardware abstraction layer? Okay, Venkatas, you have a question like API. What is in C and C++ for driver developing? So basically, driver developing is based on hardware, right? So this C and C++ code is written by the guys who have created the hardware. So because they know what they have developed in their hardware, right? So it actually is based on the hardware, right? So see, let's say if you have created a hardware, so you know what you have done there, what request you have to send, what signals you have to send, right? So that is based on basically that things are mostly done by the embedded guys, right? They created their hardware and then they create drivers. So there is no common in, no, I'm not getting this last line. So you want to know that there is no common in C, C++ and Java API like web services. So you are asking that driver of different applications are different. Yes, obviously driver of different applications are different because every hardware has its own implementation, and based on their implementation, the drivers are different. No, it's a open source, right? See, basically Android is open source, and if you go for go and it's internet implementation, you this is open source. If you know how to write a driver in C, C++, you can just open your mobile, change the camera, right, and reinstall the operating system. So this is open source. It's based on you, what you want to see. Many companies, many small companies, what they does, they get the parts from the countries like China, Korea, right? Like Micromax, it's also do the same. Like they get the parts from the different countries and then they assemble it in India, right? And they have customized the Android operating system. So you can also do this. You can get if you have proper knowledge of hardware, right? You can get the hardware, right? Create your own mobile. Android is an open source, so you should know that okay, you are creating Android phone, then you must get the hardware which is compatible with the Android, and you can create your own mobile also, right? But basically, this is a teamwork. One single person can't do this because you have a proper knowledge of software, you have a proper knowledge of designing the kernel, installing kernel, then you have a proper knowledge of C, C++, hardware. Basically, it's a teamwork. So if you have a different person of different technologies, you can create your own, right? Okay, now coming to this native C++ libraries. See, now native C++ libraries. This is something different. Something different than this kernel, right? This is a native library which is based on C and C++. Now, let me give you an example. OpenGL Okay, so we have native C and C++ libraries, which is used for many things. Let's say if I talk about this OpenGL this is used for image processing. This is used for media framework, WebKit, that means for web browser, OpenMaxAL, library C. So let's start with very few examples. Let's say OpenGL I used it for image processing. Let me give you an example of games, right? In a game, what we do, we are just playing a car race game, right? I press accelerator, my car start moving, right? In a fraction of seconds, what actually happen is many images, right, are moved from one frame to different frame. Let me draw this. My car is moving from this point. My car is moving from this point to this point, from this point, right? Let's say it's moving from one coordinate to other coordinate. Right, so in a fraction of seconds, thousand of images, 100 or 1,000 of images are moving, right? And these things can't be handled by Java. For this, we need a rich API which operates the images, right? Before that, let me give you one more example. This is your camera, right? This is your camera, right? You open your camera, you start video recording. What actually happened, or you are going to open a, you are just going to click a picture. So what actually happened is, let's say I have, okay, let's say I have mountains. Let's say these are mountains. Now I move this camera from this side and this side. Now, when you move your camera left, right, up or down, you see the images are continuously changing on the top of your mobile screen, right? But if you think your mobile is only a hardware, when camera is off, you open take your camera on the top, you see you can't see your hand back, right? Because it's not a transparent thing, it's not a glass. What actually happening is, you have a camera, let's say if it is transparent, it is located somewhat here, right? This is your camera, which is on the other side of mobile. It takes the picture, right? See what happening is, this is your camera, this is your screen, let's say. It takes the picture, send it to the screen, right? Takes the picture. What camera is? Camera has a lens take a picture, right? In a similar way, how our eyes see the things, right? Camera takes the picture, send it to the driver send it to the display. Now it draw it continuously on the screen, near the top of camera screen, right? In the top of camera screen, that means this one. If you move your camera, image changes, right? If you move your camera to the left, you can see the next mountain. If you move your camera to the right, you can see the next mountain. If you open the front camera, you can see yourself, right? So what happening is, continuous rendering of images is happening where on your display, right? Thousand and thousand of images are rendering itself, right? You know how image works. Image works when you see movie, right? When you pause the movie, it stops in a frame, right? So a video have 1,000 of frames per second, right? So if a person is running, that means that person has 1,000 of frames, and that frames moves continuously, and it seems that that person is moving, but actually video is nothing. Everything is an image, right? Image and the speed in which the image is changing, right? That actually happens in a fraction of seconds. In a fraction of second, image is changing, and it seems like we are seeing a video. Same thing happen in the camera, right? Your camera takes pictures continuously, and it changes this picture continuously in your mobile screen. And it seems that when we move our camera, it seems that okay, we are capturing the live recording, right? So if you do this thing with Java, what thing? Operation of image, or you can say rendering of image continuously on the top of mobile, you can't do this, right? For this, we need a rich API which is able to uh, handle images, right? For this, we have this OpenGL ES. OpenGL ES is a language for uh, handling images, right? And it is basically based on C and C++, right? So similarly, we have WebKit. You open the WebKit, right? And when you open the browser, you see variety of things like the your browser support JavaScript, right? And other things. So this is also a code which is written in C, C and C++, but they are libraries. They are not the driver things. They are something which is written in C, C++ to operate the data. Media framework, you open the, you want to see the like video of, let's say, .aac format, .arc format. Now, with the help of Java, you can't do this. For this, you need a library which runs in a C and C++, right? For this, we need a native C and C++ libraries. This is here they have shown only 4 or 5 libraries. We have hundreds of libraries which you can use, native C++ libraries, right? So basically, this is for uh, handling the data, right, which can't be handled, or data or operation which can't be handled by the Java, like this example which I have given you, right? See the definitions also. Native C and C++ library. See, many core Android system components and services such as ART, HCL are built from the native code that requires native libraries written in C and C++. The Android platforms provide Java Framework API to expose the functionality of some of these native libraries to apps. For example, you can access the OpenGL ES through Android Framework, Java OpenGL API to add support for drawing and maintaining the 2D and 3D graphic applications, right? This is the example which I have given you. Actually, we have a class known as Surface Manager, which works for the camera, but actually internally it uses OpenGL ES. Now, if you want to draw circle, let's say, if you want to draw circle and draw some rectangle lines, you can use simple Java language, right? But if you want to do some, let's say if you want to make a game, right? Game has a lot of graphics. For that, and you know only Java, right? So you can use this library, OpenGL ES, right? This library has a layer written in Java, right? The same layer which we were discussing here, this layer. The library is written in C, C++, but you have a handler so that you can talk with this C and C++ code, right? If you want to if you want to draw image method, right? So I'm just giving a sample example. Draw, you will call it draw image, and the image will be drawn. Basically, internally you are using C and C++, but in front end you are writing a Java, right? So you have a handler. This is your OpenGL ES, right, for performing 2D and 3D graphics. And if you want to handle this, you can use Android OpenGL, right? You don't have to know C and C++. What you have to know this OpenGL ES, which is written in Java for Android, right? For using this, you can communicate with the libraries which is written in C and C++, right? Similarly, we have other libraries like for WebKit, for media frameworks, right? So now we have Linux kernel, hardware abstraction layer, and native C and C++ library. Now we will discuss Android runtime. Okay, now let's discuss Android runtime. So this is on a important part of Android. Here we will discuss Android runtime. I will explain you how Android code works, what we compile, how we compile, what we get. So let's move forward. Okay, now let's see. When I say compiling Android, I'm talking about Dalvik virtual machine, right? Everyone knows Java virtual machine, right? Java virtual machine, JVM, actually it is used for compiling Java code, right? So first we will discuss how Java like JVM works. Then we will discuss how JVM. I write code in JVM, right? And what JVM does, JVM, let me write one more thing. I have a code in Java. I'm not talking about Android right now. I'm just talking about Java, JVM, right? I write a code in JVM, Java. My source code is in Java. Now, the second thing which happened is my code changed to, let me write, with the help of compiler. You can say the compiler is Java C, right? Yeah. This then this convert the code in .class file. We compile it, we get .class file, right? Simple. And .class file is what? It is a bytecode, right? Now what we does, then we send this to JVM. Now JVM comes in a picture, send it to JVM, right? Java virtual machine. And this Java virtual machine is stack-based software. So this is simple, right? We get the Java code, Java source code, we compile it, we get the .class file, we send it to JVM. This is actually how Java compiler works. So this is very simple explanation. Now coming to Android, what actually happen is we write a code in Java, right? Then Java compiler, which is your Java C, right? Your Java C compiles it, and then we get a .class file, which is a bytecode. Okay, you get a .class file, which is a bytecode. Now, compiler comes in a picture known as a text compiler. Now, this text compiler converts this .class file into .text file, right? Java converts your basically your Java source code. Let me change this to Java source code. Source. So this is your Java source code. This is compiled by Java C. You get a .class file. Now we have a DEX compiler. I will explain you what is DEX compiler in a few minutes. This creates .text file, right? Now this text file is given to DVM, known as a Dalvik virtual machine. Okay. Now we have some virtual machines. In Java, we have JVM, Java virtual machine. What it is used for? It is used for basically reading. Basically, you can say the reading the byte codes, right? So virtual machine reading or operating, right? Consuming whatever you say or handling the byte code. In Android, you can't use JVM, right? Because JVM is not lightweight, it is heavyweight virtual machine, right? And in mobile, we have a limitation of memory. So for mobile, for Android mobile, we have they have basically created a compiler, or you can say the virtual machine known as a Dalvik virtual machine, DVM, right? .dex file. So we have a DEX compiler, right? We have a Java source code. We run the Java source code. It creates .class file with the help of JavaC, right? Now you get a .class file. Now this .class file have to run in a mobile. Now in mobile, which compiler is working? For mobile, which compiler is working? DEX compiler. Now DEX compiler convert this .class file to .dex file. Right now you have this .dex file. This .dex file is given to Dalvik virtual machine, which is your mobile, right? And then it virtual machine compiles it, basically not compiles it, it operates it, and you can see your application basically. So this is the flow. Now if you see here, we have .java file, then we have .class file, and that converts in a .dex file. Let's see the definition. Dalvik virtual machine. Provide environment on which every Android applications run, right? Each Android application run in its own process with its own instance of Dalvik virtual machine. Dalvik virtual machine written such that device can run multiple virtual machine efficiently. Now come back to our whiteboard. Let me explain you one more thing. This is your phone, let's say. Now whenever your phone opens any application, let's say I have an application this. Okay, now you have this application, right? Now what actually happening is, whenever you whatever the screen, yeah, process, right? Okay, now I have a kernel, process, applications. Kernels open an application. Let's say application 1. Rename it to A1. Similarly, I get A2 application. Similarly, I get A3 application. So I have 3 applications, A1, A2, and A3. A1, A2, and A3. Now, when application A opens, kernel will start a process for application 1. When application 2 opens, kernel starts a process for application 2. For application 3, right? Number of application open, kernel starts a separate process for every application, right? Process, what is process? This is a thread. Your kernel start a separate thread for your Android applications, right? And actually this is known as a main thread. If you are comfortable with threads, if you know what thread is, you'll understand what I'm saying. Process, let me say process. Process, that means kernel starts a new process for application 1, because see, kernel is handling the application 1 or opening the application 1. So basically it needs a new process, which is known as a thread, right? So if you don't know about thread, right, I recommend you to see the basics concept of threads, how it's work, right? For now, I'm not going to explain thread, but I'm going to explain a very basic what that means. That means kernel A is going to start A1. That means application A1. For that, it will start a new process known as a thread. For application 2, it will start a new process known as a thread, right? 3, new process, which is known as a thread. 4, for every application, we have a main thread. right? And what main thread is? Main thread is the process which is started by the application, which is started for the application by the kernel, right? So this is what written here. Each Android application run in its own process, right? With own instance of Dalvik virtual machine. Each application is running in its own process, right? And every process have its own Dalvik virtual machine. But it means application open by the kernel creates a process, and every process has its own instance of Dalvik virtual machine process. That means every application have its own Dalvik virtual machine. Or you can say every process starts a Dalvik virtual machine for your application, right? So A1 have its own Dalvik virtual machine and process. A2 have its own Dalvik virtual machine and process. Similarly, A3 has its own Dalvik virtual machine and process, right? Dalvik has been written such that devices can run multiple virtual machine efficiently, right? Device, that means your phone, right? Virtual machines are very heavy, right? Like virtual machine, Java virtual machine is very heavy. But Dalvik virtual machine is written in a way so that your application, right, multiple virtual machine can run efficiently in a device. What it means is A1, A2, A3, all these applications have its own Dalvik virtual machines, and number of applications you open, it will have its own Dalvik virtual machine, and that will be handled by the device, right? And why your application have its own Dalvik virtual machine? Because remember what I have told you, this sandbox. Every application run in its own sandbox, right? Inside its sandbox, it has separate virtual machine, Dalvik virtual machine, and this is started by a process, right? This is the memory area initialized by a process, and that process is initialized by a kernel, right? So now if you think, now you can think that, okay, application starts by the kernel. I tap on the button, it starts the application starts, and kernel starts a process. It starts a sandbox, right? And after the sandboxing, right, it get a whole series of work, right? Your application open, right? You get a new instance, a new process is started, a new Dalvik virtual machine is started, your application is running in its own sandbox, you can't communicate with the other processes or other applications, right? And the next line is, it's a register-based virtual machine, right? So register-based virtual machine, so Dalvik virtual machine is register-based, and this is how it's work, right? I have explained you how it's work, the flow, Java code that converted into .class file, then it's create the text file with the help of text compiler, then at last Dalvik virtual machine, which is in your every application, operates this text file and your application runs. See, we have register-based virtual machines and we have stack-based virtual machine, right? Register-based virtual machine, that means we have the entries of virtual machine. Let's say virtual machine is running your code, right? So it enters the data, that means it information or handles the information with the OS registers. In operating system, we have registers. We have many registers, right? It work with the help of these registers. So basically, it is a operating system thing, right? In operating system, we have registries, right? Registries basically that that have information about your application of your hardware, right? We have type of registry like temporary registries, we have permanent registers. So basically it is based on that protocol. Okay, so this is our Dalvik virtual machine, right? executing the Dalvik executable .dex format. .dex format is optimized for minimal memory footprint compilation. So this is the same thing which I have told you, that Dalvik virtual machine is designed for lower memory devices, right? So it is obviously designed for optimized minimal memory footprint, right? Relying on the Linux kernel for threading low level memory management, right? Threading, that means your process, this thing, process, and low memory management. So it's a simple thing, right? It's Java source code that compiled with the Java C. Then you get a .class file. Dex compiler give you the .dex file, and this .dex file is understood by your Dalvik virtual machine. Okay, now moving forward, we have one more thing which is known as ART. Right? It is a next version of Dalvik virtual machine introduced in the KitKat version. Right? So Dalvik, now many devices are machines are there, or can say many devices are there which supports Dalvik, and many machines are there, or the virtual machine are there which support ART, right? So it is the next version of Dalvik introduced in the KitKat. Dalvik is the runtime bytecode and virtual machine used by Android system for running Android application. Right? ART has two main feature compared to Dalvik: ahead of time compilation, which improve speed, particularly startup time, and reduce memory footprint, no JIT. Improve garbage collection. So let me explain this 2 lines. JIT, just in time compilation. Just in time compilation, that means actually Dalvik was based on just in time compilation. JIT, just in time compilation. Just in time compilation, that means you open the application, right? You have a .dex file. Internally, .dex file have all the Java codes, resources, all the thing. Just in time compilation, compile your code at the time when you open the screen. Let's say I'm giving an example. You open the screen, you see the UI, user interface. You send a button, you send a request to cloud, you get the data. Just in time compilation does all those things at same time, right? Compilation is done at the same time when you are operating the application, right? But we have one more concept, AOT, right? Ahead of time. We have one more concept, or you can say we have a new version, enhanced version known as ahead of time, right? But see, these two are different. You can't say JIT, AOT is a next version of JIT. AOT is better than JIT, but they both have some drawbacks and benefits. I will tell you. First, let me explain you what is AOT, ahead of time. Ahead of time, that means your application compiles all the codes whenever you are installing your application. Let's say I'm installing the application at the same time. It will compile all the code, right? Compile all the code and it will keep it in the memory area, right? Ahead of time, that means just in time was compiling the code at the same time when you are doing the operation. This may make your application slow, but ahead of time will not compile your application when you are operating the application. It compile it compile it at the time of installation of application, right? It will take installation time more, right? So installation time will be more because at the installation it will install the application and compile all the code and keep it in the memory area. Now whenever you are operating the system, it is not going to compile. It is already compiled, right? Then it is fast. ahead of time is fast than just-in-time compilation because it does pre-compilation, the time of installation. But it compile the application, keep the data in memory, so it will occupy the memory, right? So it will occupy the memory, right? So when I say it's occupy the memory, that means your application is compiled and data is in the memory. But if your application is too large, it will occupy larger area. That is not good for the this is not good for the phone if your phone has lower memory, right? But your application don't have like your application size is not big, then you can use AOT time. But it's not on you, it's on your phone. What your phone is using, AOT or JIT, right? So AOT is fast as compared to JIT. And if you talk about ARD, Android Runtime, right? It is the next version of Dalvik virtual machine. It used AOT compilation, which improves the speed, right? Why it improved the speed? Well, this is the reason which I have told you, right? Previously, it was using JIT. Now, the Dalvik have two versions, one version with JIT, one version with AOT, right? Okay, and it has one more feature, which is improved garbage collection. Garbage collection, that means your application, not only in Android, not only in Java, C, C++, or other languages, they all have garbage collection. Garbage collection, that means the cleaning of memory area which is not in used, right? Your application creates multiple temporary objects, right? Let's say you have created an object, now that object is not in use, then garbage collection come and it's cleaning, right? It will clean the memory area. So here, all the things are same. We have resource, native code, right? Then we have source, we have text file, we have APK, right? See, this is APK. Basically, APK is like when you create a phone, like the application in .NET, we get exe. When we create the advanced Java, we get a WAR file or jar file, right? Similarly, in Android, whenever you create application, you get a APK, right? It's a zip file basically, and this APK is going to install in your application, in your phone, right? And whenever you install it, we get a text file, we get a resource and native code. And this is the Dalvik, actually, the structure of Dalvik. This is a JIT and this is the ART. This is the difference between JIT and ART, which I explained that at a time of installation, ART will keep all the information and JIT will do this at a runtime, right? Okay, so any query, guys? Now coming back to the thing which we are discussing. Now we know Linux, we know HL, we know native C++ library, we know runtime. This is a core library basically. Core library is Android library, right, which is used for basically you can say this core library. Previously it was shown like this. It is a support library of Android runtime, right? So Dalvik virtual machine is running. To run Dalvik virtual machine or the processors, we need the core libraries, which are supportive libraries, right? So it is a part of Android runtime basically, right? So now we are going to discuss about Java API framework. Now we have discussed 3, or you can say 4 things. We have 2 remaining. Okay, now moving to the next, second last layer, which is Java API framework. So this is your actual Android where you are going to work, right? So you have Android SDK, Android Software Development Kit, right? And that is actually a Java API framework where you are going to work and sorry, where you are going to create the application using these APIs known as activity, location, packages, notification, window, telephony, resources, view system, lot of things, right? So this is your Android SDK where you are going to use, and using this Java API framework, which is your Android SDK, you are going to create application known as dialer, email, calendar, WhatsApp, Facebook, XYZ, anything, any your application, right? So this is the kernel. Using kernel to, this is a kernel for drivers, and to handle this driver, we have abstraction layer so that you can handle this driver. On the top of it, we have native C and C++ libraries, which is used for handling the things like for handling the images, for WebKit and other things. Then we have Android runtime, right, for compiling the Android code. Then at the top of this, we have a Java API, and then we have a system apps, right? This calendar or camera, let's say this email application, it is written in this Java API framework, right? Below that, when you run it, if it is using the mail or if it's using the WebKit, it might be using any native C++ library. If it is running, that means it is using this Android runtime, right? And below that, it had abstraction layer, and internally everything is handled by the Linux kernel, right? So this is the Android architecture, platform architecture, right? If you have any doubt, you can also go through this video again, right? Okay, so which company developed Android? Android Inc, right? Android Inc developed Android, and Google bought Android Inc and working on Android. So basically, Android is a project of Google. They are working on it. Okay, now if you want to upload your application in the Play Store, let me show you what is Play Store. I think everyone know what is Play Store, but let me show you. Play.google.com. This is your Play Store, right? This is your top charts, new releases, category. You can change the category, right? So to upload your application in this Play Store, what you need is you need to buy an account, right, from the Google, which costs you $25 lifetime, right? You have to buy an account, right, and then you can upload your application in this Play Store. Okay, and Android is not only limited to phone. You have Android watches, you have Android TV, printer, right? You have Android installed in your vehicles, in your car, right? So basically, it's an operating system, right? And you have installed that on your car. That means you can connect your car. You can see where your car is in the parking with the help of Android device, right? It will get the location. You can give a print to your printer by using your Android application. See, your printer and your phone, they both are using Android application, Android operating system, right? So they know their protocols. If I send any data from mobile using Wi-Fi, Bluetooth to any other device, right, and that device might be installed on your phone, in your car, or in your printer, anywhere, then it can operate, right? It can do whatever you want from your device. Similarly, we have an oven, and we have Android locks, right? Like if you install Android lock in your home, what it does, basically, in your main meter, in your home, in your main connection, we installed a device basically, which is based on Android, and it is connected to the Wi-Fi, right? And that device know the connection, that means the switches, right? If you have in your room, if you have 5 switches, it know that, okay, now 5 switches are there. Basically, you have let me draw this. This is a switch 1, switch 2, switch 3, and switch 4. And you have electricity line of this switch. Now, you installed an Android device. Basically, not Android phone. Separate device come for this purpose. And sorry. and this device connects to Wi-Fi, right? Now you have a phone, you are also connected to Wi-Fi from this Wi-Fi or any other Wi-Fi, right? Now this device can know, okay, this switch is on or off, 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 right? That means from your home you can check, is your fan is running, is AC is on your home, is fridge is running. You can also, if you have Android refrigerator, you can control your fridge from your home. If you have Android TV and your kids are watching the TV when you are in office, you can see that, okay, my kids are watching the TV now, let's lock the TV, right? Now this is a study time. So you can do these things, right? And basically you can control your home appliances, right? Even your door lock, you can check your door lock, right? You have also, you can also see if your gas is on and off. So we have many other devices which are running in Android platforms, right? And they are basically can operate it from the mobile, right? You have a Android device which is not actually a mobile, but that can be operated by the mobile, right? So here it is shown these things. Can we release any app as a paid if we have once released that is a free, right? You can. No, you can't, right? So if you have a free, if you have released the application as a free, you can't make it paid. But you can add in-app purchase. Let's say if you have installed a game which is free actually, but for let's say if you're running a car, you need a new car. Your application is free. You have installed it free, but you need a new car, right? For that you have to pay, let's say, $2. For that you have to integrate in-app purchase in your application. It basically, when you tap on the application, tap on the buy, it will open the in-app purchase, and then you have to enter the card information or the account information. Then you can buy the car or buy the petrol, buy the guns, right? In a games, not only in games, in many applications, if you are using applications like Gaana.com, Savan.com, many other applications, in a Google Play Music also, they are free application. But if you want to get the paid one, what you can do, you can go to their account, you go to your account and you can make it your application as a paid application. For that you have to pay some specific amount, right? For this you have to integrate in-app purchase. So yes, if your application is released as a free, you can't make it paid, but you can enter a, or you can say you can integrate an in-app purchase so that user can download the application as a free, and if they want to enhance it or if they want to upgrade it, they can pay it using in-app purchase. What is the cost of Google App Published account? $25. How many apps can be released under one account? Number of applications. Okay, so now the last topic of today, downloading Android SDK and creating a demo application. Okay, for now, for developing Android, what you need Android as Android Studio, right? Previously, Eclipse, we do this development in Eclipse, but now from last 3-4 years, Android has Android Studio, its own framework to create Android application, right? So it is far better than Eclipse, right? For creating Android, for development of Android, right? Other technologies we are still using Eclipse, but for Android development, it is recommended, officially recommended. So you have to use basically Android Studio. Now, this is the page where you from where you install the Android Studio, right? Download it. It will automatically detect your laptop. Basically, mine is Mac. So if you have a Windows, if you have Ubuntu, it will automatically detect it. Download it and install it. I will show you the video of installation. I already downloaded this. So just click on Android Studio. Give the path. Next. Extracting Android Studio. Finish. Android Studio is starting. It's asking, sorry. It is asking whether you have any other installation of Android Studio, or if you want to import it, you can import it. Otherwise, it will make a fresh copy of your Android. Fresh copy of your Android. That means the information which has to fetch. Okay, Android Studio is starting. Next, standard. You can create application for these things: mobile, watch, Google Glasses, car. But we are going to do this for mobile. They're asking me that you want to go for a standard or custom, right? In custom you can do your own settings, and standard will make the settings for you. It is recommended, so use a standard. Now it's downloading the Android SDK, right? Finish. Create Android Studio project. Okay, that's finished. You can see this installation guide, right? If you need any help. So it's a very easy, actually. You have to download it, double click it, it will start uploading. It will start basically start installing the application. And if you need any help, you can see this installation guide and video. And even if you need any help, you have a email of support guys. You can mail them what you are facing. You can also, whenever you send any query to the support team, I recommend you to send a screenshot with it so that they can get they can understand what actually the problem is, right? So we have the support team, they will help you. This is the installation guide. You can take the help of this. And for Android, you must have Java installed, right? So install Java, right? Set the path of Java, the environmental path, environmental variable, then install Android SDK. All of these things are described here in the installation guide, right? To install Java, you can go the Oracle, and from there you can install Java. So it supports the latest version and the lower version also. So you can download the latest 1.8 and 1.8 JDK, and then you can download the Android SDK. Okay, now I already have Android SDK. So what I'm going to do is I'm going to create a demo application. Android Studio app. Let me open this Android Studio app. So when you do installation, it will ask you to download SDK tools, right? So what you have to do is just click the download tools, accept, do next. It's again it's download the tool. It will again ask you to download something else, right? So this process will repeat for 3, 4, 5 times. So whatever it asks you to download, just click it, accept it, and download it, right? So Android Studio is opening. This is your Android Studio. I have already installed it in my machine. It is already installed. So these are the Android storage. I very like this storage. Basically, here you can see like how developers, the Android developers or these programmers, how they get idea to create any application. They share their idea, or they share their idea how they have created their application, how they have set up their companies, right? So they're very motivational videos. Okay, so I'm going to create a new application, file, new, new project, right? So I already have Android Studio, so it's asking me to, it's showing me this screen. So from here also I can create a new project, and if I close this screen will come. When you install your Android application for a very first time, you will get this screen. Here you are, you can see the list of applications, recently used applications. Start a new Android project. Okay, so this is the first page to create an application, right? So my application, this is the name of your application, right? So let's say my first application, let's say Hello World. Hello World. Same name which is used by our ancestors. Hello World, right? And this is the company domain. Now this is the important thing, company domain. Why it is written like com.acadguild.webservices. Let's say com.acadguild. I think this is also right. This is also right, but it is not recommended to use a single word. It is recommended to use the company domain dot hello, because here in this in Play Store, your application will be identified with this package name, because this package name should be so this package name have to be unique, right? Because whenever you open your Play Store and you see there that we have many applications, when you unzip the application, you see their codes, you can find every application has a unique company domain, right? So basically you can assume that this is a unique ID used by your application, and this is detected by the Play Store whenever you whenever you upload your application in the Play Store. Play Store check that, okay, is this company domain name exist in the Google database? If yes, then you can't upload this application there, because it already have this domain name. It's simple thing as a website domain name, same thing as a website domain name. So we have to keep it unique. And also you can't install two applications with the same company domain name in a same phone. It will not allow you, right? If you do this, last application will be uninstalled and it is updated by the new application, because it treat application as a company from, or you can say it's find the company from its company domain name, right? And this should be unique. This is your application name. This is your project location, right? For now, I'm just going to create this in a desktop. Right, so in a desktop, I want to create a Hello World folder. Inside that, I want to create my application. If you want to give support to this C++, you can check it. If you want to give a support to Kotlin, you can check it. Package name is hello world acadguild.com hello world, right? Because this word is hello world. If you want to remove it, you can remove it. Now this is right, because by default it will append this application name at last. Previously it was not like this, but in a new version of Android Studio it is like this. The application name, if you change this hello world, hello acadguild world, see, this is now changed. Package name is now changed. You don't need to write dot name of application name. It will automatically append by the package, by the Android Studio. Now press next. Now it will ask you what support you want to give. I have all these things installed in my in my SDK. So I want to create it for Android Nougat. If you want to create it for Wear, TV, Auto Things, Android Things, classes, you can do this, right? I'm not going to do this. I want to create it for phone and tablet. Next. This is some predefined templates, right? Some predefined templates. So I'm just going to create this empty activity. If you want to use this master detail, navigation, scrolling activity, basically it will give you some previously defined classes in UI designing, right? So let's do something. Let's use this one, basic activity. Next. Activity name. Activity, for now, understand activity as a UI, right? So it is asking for the UI name and the UI, which is handled by its class activity. We'll discuss this, don't worry. So for now, let's say hello world activity. Hello world activity. And this is the layout name, XML file. This is a title. If you want to use a fragment, you can click. If you don't want to use a fragment, you can check it and check and then check it. We'll discuss about a fragment. It's also a very big topic. For now, just concentrate on how I'm creating the application. Finish it. Wait for a few seconds or a minute. We'll create the application. So building the application. Hello Gradle project info. Your application is creating, building. In third session, we will discuss about activity. In next session, we will discuss about, we will discuss the project structure, what project structure look like. We will run the application. We will see how Android, what is Android virtual devices, and we will also create a UI, right? Okay, so this is my application, right? This is my app, and this you can see this is a structure. If I see the resource, I have a layout. This is my layout, right? And this is my layout. It's actually loading it. So I've just cleaned this code. Go to your code, sorry, build, and you can clean and rebuild it. So tomorrow we'll discuss what that means, what is Gradle, what is virtual device, and all other things. So this is how we are going to create the application, right? We'll discuss about this structure. I hope you guys like the session. So have a good day, guys.
A cat killed. Average is dead.